Okay, so Daryl Herzmann has coming here from Iowa State. And I have known Daryl for very short amounts of time, just this afternoon. It's the first time I've met him, but we've used his stuff for many, many years. And I was asking how this came to be. And it came about by individuals who just, taking advantage of some free time and playing with data. And so for all of my students, for anybody who knows anything about meteorology, and this is a field of science, get into computers, get into programming. We geeked out all afternoon talking data and analysis. And so this is kind of a geeky thing, but it's really the fun part of it. You get to make cool pictures, you get to know a lot of cool things. And Iowa State has become the central hub for all things weather. So if you need information, I think, are you better than the NCDC? Or
Well, NCEI, but...
And whatever they are called now, I think you've got more stuff.
Yeah.
It's more fun.
Maybe.
So Daryl is going to be talking.
It's more fun, yes.
I like this. Using the IEM, which is the
Iowa
Environmental Mesonet for fun and or profit. So please welcome Daryl.
Thank you for having me out, and Paul and Gilbert can be blamed if this talk goes up in flames. But so I'm Daryl, and you say it really nasally like a Midwestern would. So Daryl Herzmann. I grew up in Northeast Iowa. I'm 45 years old, believe it or not. So I've been at this game for a while, and I grew up on a dairy farm. And you'd see the forecast on TV, and they'd have 3 days of the sunshine icon. And we think, oh, we're gonna go mow hay today because we're gonna get 3 days of sunshine. What would happen? The second night it would rain, of course, and the hay gets washed. When you're a farmer, you don't want your hay washed. And so I got so upset about this. This was when I was in high school. And I said, I'm going to go to university and fix this problem so farmers get more accurate forecasts so we can cut hay down and not get it rained on. So I ignorantly thought I could fix this at university, and 20-some years later, I still haven't fixed it. But I'm here to talk about data. But I did get interested when I was in my undergrad at Iowa State in data, as Paul mentioned, and I've just been doing that ever since. I just have a bachelor's degree, and that's all. Sorry. But so I'm a weird kind of cookie that I've stayed in my position where I have for all those years. So the first, I only got one meme, and this is right off the bat, so you're not going to get too much entertainment here. But the fun part about my project is that, and it's just me for this project, but the name Iowa Environmental Mesonet really makes no sense when you look at the website, what's on it, right? If you think about mesonets, you think about Oklahoma, you think about New York, you think of everywhere else. We don't have a network. Iowa State has a small, modest research network, but that is not this. It's called something else. We originally coined the term Mesonet just to describe a collection of data. And we were trying to basically do something on what Meso West basically was doing at the time, and what they still do today. We're trying to build a Mesonet in Iowa, but we're not to this point yet of having an actual traditional Mesonet. So if that ever happens, I'll be the last to know probably. But anyway, so the Mesonet term doesn't really apply. Environmental in the name is actually accurate because we have more data than just temperature and precip. So we're not just a weather sort of network. And Iowa doesn't apply because we have data for all over the globe. So my attempt at being funny here is just, I'll just read it for what you guys can't see. It says, I want KDPA data, which I think is your guys' airport call center sign. And you say, well, IEM has this data. And he says, well, KDPA is not in Iowa. And he goes, well, tell them to go to NCEI then. And he says, well, I don't write in Fortran. And one of the reasons I continue to be in business after 20 years is that NCEI continues to do crazy things I have no idea. I mean, they literally must think that everybody in the world uses Fortran. I mean, because that's what their formats are geared for. And who in this room uses Fortran? Oh, don't raise your hand.
He's looking for a job.
Yeah. Right. It continues to blow my mind. And at the end of the slide, and every slideshow I give the same standard last slide. I said, I hope NCEI puts me out of my misery. Because my misery really involves trying to curate and disseminate a lot of data sets you just don't find anywhere. And that's sort of like, I guess, a pride point for me, is that some of these data sets I want to show you about, you just literally can't find it anywhere. And there's reasons for this, but we can go into some of that. Please interrupt me if you don't like what you see, if you want me to ask something you see on the screen upsets you, whatever. So you get this fancy little icon, which we made 20-some years ago, and if you see this on logos or stuff, that's me. There's nobody else at the university that knows about this project, and this is me. So anyway, so what is going on here with this website? So you go to this thing and it's just crazy, and you think NCEI has got a bad website, and I always basically compare mine to theirs. We're number 1 and number 2, however you want to rank us for worst organization and data. But the problem is, and I'm really a sucker for this, is when people email me and Twitter or whatever else and ask me to do something, I just do it. So if one of you guys send me an email tonight saying, can you have this data set on the website, I'm probably going to do it the next day and just be done with it, right? And so that's what ends up happening. So we get unmitigated feature sprawl, all sorts of apps, download portals, something called automated data plotting, which I'll talk about in a little bit. And I get more emails and questions about this, and I try to stop it. So a philosophical thing I want to talk to you about is that I consider every email a bug. If somebody had to email me a question about something, it's a bug. It's a bug in my website, it's a bug in code, it's a bug whatever else. How do I stop this email from coming in? And so I go to the website and try to retool something to fix this bug, and so I hope I never get this question again. So it's sort of a mentality to take for customer service and other things. And so every day, 2 or 3 new things show up on the website, and people just think, oh, what's going on? So it's more philosophical stuff. So I have subversive and altruistic goals. Altruistic is a nice academic word that means like, oh, I like to do things for the public good, and since I'm in university, I can get away with murder, basically doing whatever I want. I don't have to have any sort of liability issues. I'm not a private sector company. And so what I really like to try to promote, and some of the things that Paul mentioned I would like to talk about today, is GitHub and other things, but reproducible open workflows. And this is something that funding agencies are much more akin to now, having open data, open workflows. But what does that actually mean? What does that look like? And so one of the things that frustrates me and others that you see on many websites is you see this fancy visualization. All this neat data that shows up and is nicely organized. You can't go find the plotting script for that plot. You can't download the data out of that came into that plot to make it more extensible. So these are sorts of things that I consider to be a bug if it happens on my website, and so I try to make everything extensible. So what I use extensively is GitHub. And who uses GitHub in this? Oh, you can admit to it. It's not a big deal. Yeah, it's cool these days. And so, and it's cool is that Microsoft, right, has bought GitHub, right? So it's a Microsoft product. What GitHub really is it's a mentality for sharing and developing code, but it has many more bells and whistles on it that are really amenable to what we need to be trying to do as far as open science. And so I want to talk a little bit about that. So I mentioned a little bit before about doing small things well and iterating fast, and so having a lot of changes to fix things and move things forward. And my situation is unique, right? Because I have no bosses over me or anything like that. So I can iterate fast and do a lot of things because I'm basically on an island. So if you ever would like to live on an island, you can come live with me, and then we'll figure out who has to leave. The other thing, and this is philosophical about the web. Gilbert, you're an old one. What was one of the?
He's not wrong.
Oh, okay. What was one of the premises of when the World Wide Web was developed? What was one of the key components of what URL means?
What does URL mean?
Yeah.
Oh,
Universal Resource Locator. What does that mean? It means that they're entities, and these entities have URLs associated with them. And what that means is that a URL is supposed to be stable. It points to an entity. So when you have various websites, whether .gov, that makes things not stable, this is a problem, right? You can't say, oh, look at the neat AFD that Chicago just wrote, and send somebody a link to it. Well, if you send them a link to forecast.weather.gov and they go to it tomorrow, the AFD is gone. Yeah. That URL is not stable.
It could be gone in 5 minutes.
It could be gone, yeah. It could be, or for anything. Yeah. And you guys, your guys' website does this well too. There's a lot of URLs that are stable with the WMO headers in them and the timestamps in them, so that when people link to them or create links to them or reference them, they get it the next day. And that was always what drove me crazy about the internet for weather data. And you can go all sorts of places on the internet and find current data. It's not a problem. But to find things that are stable that you can come back to the next day and the next day after that and into perpetuity. Now, of course, I can't be sort of an academic high horse here because of my thought is I'm going to get hit by a side bus at some point, and then all my stable URLs are going to die anyway. So, but this is sort of the thing they should, I got to stay in the box. You should be a goal in your life, right? And then enjoy the irony. I get a heck of a kick out of when I get some of these emails from crazy people. And I'm in the middle of a cornfield creating services and stuff just out of the blue here. One of my favorite ones is the State Department. The State Department, U.S. State Department, has a learning guide for interns to do nuclear fallout exercises. And they pointed to my Windrose tool. and go to this WinRoads tool and figure out where if a nuclear bomb happened, where the cities would be hit. I think it's irony, but anyway. So I enjoy this irony, and that these data sets are used all over the place. So GitHub, what's the importance of GitHub? GitHub can be scary for Git and stuff like this, right? But just think of it, it's just a way to do community-based code development. The open source licenses are important and everything like this, but just from the fact that you have these open methodologies and tooling that's freely available to people like you and I to generate data sets and workflows in the open public, and hopefully make them more reproducible. But from a basic standpoint, you don't have to worry about, like, all my code that I have on GitHub, there's not much use of it outside of like making the code really robust. But people are looking at it and reading it and looking for inspiration. And that's what I think is a really good thing. So you don't have to get this paradigm of saying, oh, my code's not good enough for people to use. Well, don't worry about it. Just put it up there so people can see it and be inspired by it. And perhaps do it correctly at some point and tell you about it. But there's a lot of free tooling on GitHub that is very useful for what we need to do, including something called continuous integration, which basically means that when you do some code commits, you can have automated processes run over that code to generate reports about code coverage and other things like this. They got a lot of free AI, open artificial intelligence tools like CodePilot that can run over your code for free for academia people. And they got lots of different projects that have community tooling that do various automated checks for free on your software. What I really like to do is to watch over the shoulder of giants, which means that there are big players in the meteorological software development that are on GitHub. You can subscribe to their repos, you can watch their issue tickets, you can see what they do for commits, you can see what they do for pull requests. It's very satisfying to be able to watch these people work and how they organize their work and learn from this, their workflows. And you can see the big players on there now, like NCEP has a presence on GitHub, NCAR, of course, has a presence on GitHub, and the number of the weather models now are openly developed on GitHub. Not well openly developed, but they are developed on GitHub, and other things. But I also like to use GitHub's tooling to subscribe to repos. And what you can do there is you can select different levels of subscriptions, but the one I like to subscribe is just turn everything on for a couple weeks. And so you get all these emails coming for a couple weeks on different things. Like one of the ones I've been addicted to lately is the NetCDF CF conventions email list, or the discussions that go on. And I don't participate in them, but I just read them all and try to learn something from that. But also, it also is a nice way because you can partition up with Git things called GitOps and other things where you can do local development, push to production through all automation. That's over people's heads. Anybody got questions about Git or GitHub? The fun thing about Git is everybody says it's so complicated. I think I use a total of 4 Git commands. Push, pull, fetch, checkout.
No commits.
What's that?
No commits.
Add. Okay, that's another one. Add. I lied. 5. RM 6. MV 7. Oops. All right, maybe you need to know 7 commands. But if you ever want to get, the scary ones are when people do like these crazy branching and rebasing and all this stuff. All right. So the websites of interest. I'm going to get more onto the meteorological stuff here. So these 5 websites here I sort of highlighted are, who's ever used any of these? If you launch GR and you pick the Iowa State free web server,
Oh, yeah.
that's me. Yeah. Anyway, so the ones, of course, the Mesonet one, the MT Archive one, which has gotten nice support from Unidata over the years. And I'll talk a little bit what's on all these ones. I have one for MRMS that gets somewhat used for archives of MRS data. And then the MedFS1, which is more like the community. There's real-time IDD data that comes from Unidata and stuff like that. All in all, it's about 300 terabytes of live data, which means that you can automatically download stuff without doing any queuing and stuff like that. There's tens of terabytes, about 10 terabytes of Postgres database stuff that drives a lot of the web services you see. I get about 200 million requests a day. I don't know, what does COD get? You guys,
We get about 20. On our best day, we've gotten 40.
million.
Yeah.
Yeah. So I'm better than you. Anyway. But it's about 250,000 unique IPs. What's fun though is that there's actually a couple of different CDNs. We were talking about CDNs before. There's 2 CDNs in front of me which I don't see any of the traffic for. I have no idea what's coming to those, but which is kind of, so it could be higher. So I'm big in port RAM, thumping my chest here, but it's a nightmare. It's 30 servers and some 33 different data centers, and what a mess. So the IEM website looks like this, partially looks like this. I just want to talk about a couple things that you see on the homepage to try to look at first. The first one is this NWS users section up here, which I think most everybody here would qualify as. You go in there, you see all sorts of different links to different products. The next one is on the right-hand side where it has the most popular. There's an automated data plotter link, which will show you some of the plots from that system. And then on the front page, I have a daily feature. So every day I try to write something interesting and relevant, mostly for Iowa, but other places. But there's a couple important things that this page is doing. One is that there's often a blue button below the visualization. And the blue button says, take me to where the website, within the website where this visualization was generated. You click on that link, it goes to the visualization, and you can change all the plotting stuff, and you can download the raw data for it. So I'm trying to be reproducible in that regard. Below that, it's hard to see on this visual on the screen, but there's 3 buttons. One says how you can vote. You can vote good, you can vote bad, and you can abstain. And so I'm the only website out there, I think, where you can actually abstain from voting for whatever reason. And the reason is this kind of funny story. There's weather service people that like to give me a bad time, and some of them will never vote good on my features because they just want to spite me. But sometimes I'm got a really good feature, and they can't vote bad, so they want a third option, which is abstain. So they can just say, I'm going to abstain from voting, which means I actually voted good. So the data plotting tool generally looks like this. Up at the top, you have a pull-down menu for the 240 some options that are available. Then the next section appears with the different options for that plotting application. There's a brief description, and then the visualization will hopefully appear below that. And then below that, there's 2 buttons that says download as a CSV or download as Excel. So let's talk about Excel. Excel gets a lot of negative feedback from people. Say, oh, if you use Excel, you must be not very smart, right? So who in this room uses Excel? Not very smart, not very smart, no. Right. But it's frustrating me because there are some people in our discipline that says we cannot give our data sets out as Excel because we don't want to cater to those people. I'm like, really? I mean, the whole world uses Excel when we want to hide our data sets from them, or we're just going to generate netcdf files, and that's up to them to be able to do whatever you want with it. Just give them an Excel file. And so as much as I can on these various download portals and whatever, there's usually an Excel option. People love it. And it's not necessarily from people in our own discipline, right? It's the many other hundreds of thousands of people that are trying to get weather data. And I don't try to be pious about that. Am I doing so far? Everybody's dead from sleeping or food coma? All right. So let's go through some plotting applications, just in general. So these are just 2 colorful plots. The trick to these, though, if you see them on Twitter or something, or you see something that's been generated that's shared with you, is you look in the right-hand corner of these plots, and of course you can't see it on the screen, but there's a little section that says auto plot number something, and it's just a numeric number between 0 and 240 or so. You take that number and you go to my website and put it in the search bar, it'll go right to the page that generated it. So that's the trick. Like this one came from, I don't know what, it's 190, oh, number 70. Yeah, so you go up on the website, put 70 in the search bar, hit enter, and you'll get to this page, for example. So that's a quick way and handy way to do it. In this case, what it's visualizing on the left-hand side for Chicago, it's just the period between the first and last severe thunderstorm for each year, and then the tick is the number of daily events throughout those years. And then on the right-hand side is just sort of overviews, whatever. And on the right-hand one is a plot of cloud aviation, cloud flight category, instrumentation category, so LFR, IFR, whatever. Quick, simple visualizations. So what I'm trying to do with these tools is, as I offer the raw data for download, some people just want the visualization, or they want to use this for whatever sort of display. They don't actually have to get the data and try to process it. Whoever ever tried to process METAR data into the aviation flight conditions, oh, let's not do this. So I try to do it for you. So you're getting a box every hour. I'm taking care of all the specials and everything else in the world that's happening, and just giving you the data. And if you want to download this as an Excel file, you can get it as well. And I should mention, I'm getting so excited here. If you go and look at my talk, and I'll show you how to get to my talk later tonight, but every page in here has got a link to it where it was generated on the website, so you can click the link and it'll actually get direct to it. Everybody's happy? Don't be putting that on X now.
That's already up.
All right. So that's 167. And if you get really nerdy like me, you'll remember what some of these numbers are. Like autoplot 90 is an interesting one. 200 is a fun one. 220 is a fun one. Anyway, who's used autoplot 220? Yeah, it's a fun one. Yeah. Yeah. So this is the fun one. This is my acronym-heavy slide. So this is all you can find on the Iowa Environmental Mesonet website. All right. So the ASOS 1-minute data. which is a whole rant of itself. There's 2 different ADASOS 1-minute data sets. One comes from MATIS, one goes to NCEI. This is the NCEI version of that, which has less problems than the MATIS one. But you can get this data, it updates twice a day or so based on when NCEI updates, but it's much simpler to get it from my website than to try to do NCEI's files. You can do it if you want, but just, it's not the faint of heart. BuffKit profiles. Who uses BuffKit? Yeah, 1 cool kid. Yeah, 2. All right, so we have massive, massive archive of BuffKit data. And this is basically the model profiles out of the different models going back, I think, 15, 20 years now. Between us and Penn State, we have it in spades for this data set. But it's really cool to be able to go back. And there's a bunch of APIs on this now. And I forget the name, Kyle Gillette, the guy from Michigan. Yeah, he's wrote something into his app now that goes through it. But it's cool because you can get profile proximity soundings to any time in this period from the models. These are based off of a weather station location, so airport locations. So it's not true grid point profiles, but it's for the, anyway. So we got through 2 of them so far. How much time we have left? CLI data, this is another nice data set that the Water Source produces. This is the climate summary data that comes off their first order stations. You can get the atomic data out of these things. These are nasty text files, otherwise to parse through. Flash flood guidance from the river forecast centers, RFC, there's some services on this for if you want to get what the current flash flood guidance is for a particular point in the past or currently. Global METAR. Global METAR is one of the really cool data sets that I have, and you can simply download for any of the airports, weather stations in the world that report in METAR through the NOAA. You can go and download archives of this going back to the 1920s. It's really cool. Who's heard of HML before? Hydrologic, ooh, 1 cool kid.
Heard of it.
Yeah, you heard of it, okay. Yeah, it's an XML format for river stage data observed and forecast. You get archives of that. Iowa webcams, you don't care about Iowa. Local storm reports, you can get, this is different than what SPC's website offers. These are actually just the raw local storm reports all processed into like shape files or Excel files and not just the raw text. I do process all the, I process all the HF METAR data. This is the 1-minute, quote unquote, 5-minute stuff that comes from MATIS. This is the data set that you cannot use temperatures for. Don't ever use the temperature data here. Long story short, the ASOS is in the United States record in Fahrenheit, whole degree Fahrenheit. This data goes to the FAA in whole degree Celsius. What happens when you go from whole degree Fahrenheit to whole degree Celsius? You can't get back to whole degree Fahrenheit from that. And remember, kids, in METAR, when it has 10th of degree C, what does that mean? Is it 10th of degree C accuracy or precision? No. The 10th of degree C is only there for what?
Rounds to whatever Fahrenheit.
Yes. The 10th of degree C is only in the METARs to get you back to a whole degree Fahrenheit. Remember this, except for the global METAR sites where they don't have this problem of English units, right? So every time you think they, yes?
I don't know if you saw the PNS the other day.
Yeah.
They are finally going to replace the temperature
Yeah, but
point sensors.
it won't fix this unit issue. Yeah. What's next? I got it off the side ran. MRMS, not very cool anymore because MRMS is now all at AWS and Google and other places, so you can get better archives than I have for that. The NCEP models is whatever. It's not very, it's only just some base initialization fields. Again, it's all at AWS now. The live data we talked about. I do process the lightning data. We got license issues with this stuff, so I can't really do much. Oh, you're a Unidata person. Don't listen to this part. I can't do much with that data set.
Hey, so it's not public. You're good.
Yeah, I don't do anything. I only generate maps of heat maps, which I okayed with them. They're okay with that. I just can't give out anyway. NRCS scan. Who's heard of NRCS scan? These are soil climate analysis stations. They have multiple levels of soil temperature and soil moisture. There's a bunch of them in each state. We've got all that data. The NWS text archive. Oh boy, you were talking about the 1980s, storm chasing. I've got now text data from the 1980s on the website. Yeah, so you're gonna go look at the, whatever it was called at the time, the Storm Analysis Center, the storm. Yeah, yeah. Yeah, this is a cool story because, you know, of course, I got to bang my chest here about this one. Somebody hinted to me and said, go email this person NCI. They've got this old binary stuff. They have no idea how to deal with it. It's from the 80s. I said, okay, I'll send it to you. And they said, okay, we're going to give this to you, but we have no idea what it is. So I was able to, thankfully, I was able to reverse engineering this packet format they were using And I got all this nice text data from the 1980s and early 1991 that they didn't have on the website. I'll show a slide about this a little bit. It's a gold mine. It's an absolute gold mine. And what I did on the website is I rectified all the old WSO locations. So the problem with this data is that back in before modernization, there was all sorts of Weather Bureau, whatever you want to call them, offices. Yes. WSOs, yes. What I did is I moved all that data. I didn't change the text, but I classified it under the present day WFO. So if you're looking for something like from, I don't know about Illinois, but like Dubuque, for example, you'll find, yeah. So you'll find all that in Chicago's identifier on the website. The Wawa map. Folks, all am I doing is I'm just hitting weather.gov every 5 minutes and caching that image. And I have it back to 2013. It's like I walk on water when I did this, and people are just love it because you can actually go look at the Wawa map. You know, I'm talking about Wawa map. It's weather.gov's main, 1980s style map that shows all the alerts. So somebody else has done this better than me? Watch warning advisory. Am I missing an inside joke?
We do a new Wawa map.
Yeah. There's much better options, but whatever weather.gov have, I have it back to 2013, so you can at least generate what it looked like back then. So cool. PIREPs, pirate reports. For whatever reason, I'm now in the aviation data business, and I have all sorts of different aviation data sets. I don't like to be in this, but I am. Whatever. The public RWIS networks, so these are the roadway weather stations that are from states that share their data, not Illinois, but that go through MADIS. Some radar products I have are really crude. They're not cool at all. But the RTMA, I do some archiving, which again is at AWS now. Folks, you don't know the horrors of Chef. Who has tried to parse the Chef before?
Yeah.
Yeah.
It's a nightmare.
I mean, you think METAR is bad. Yeah. It's nothing. So Chef is Weather Service, whatever. Weather Service has all this cool data they collect from different partners. It's basically stage data. River stage data is most of it. But they put it out in Chef, which is the worst format you can imagine. I wrote a Chef decoder in Python. Like, look how cool I am, right? But anyway, so I have all this Chef data archived now, and it does, I think it's pretty high fidelity. So if you ever want to look for this data that doesn't exist at USGS, because USGS has authoritative archives of this stuff too, but it's there. Segments and CWAs, it's another one that is an aviation product. I got various tools to download the MCDs, the watches, the outlooks in shapefile formats and GeoJSONs, ACE and APE services, but I also have some simple tools, and I'll show this in a little bit, that you can search on the website, drag a marker and say, oh, when was the last time this point was in a high risk? When was the last time this point was in a SIG hail 15% or whatever you want to call it? And it does that. The SMOS satellite, which is a soil moisture observation, we do have some products for the Midwest. I have an archive of sounding data for whatever reason. Wyoming's is better than mine, and so it's not too exciting, but it's there. And SPC now has a much better interface for it. So I'm sort of getting put out of business for that one. That's good. Text MOS. I process all the MOS data, the great old text data, and I make it into a downloaded format. So you don't have to go download the text files with the MOS data. You can actually get a common delimited file with what was in the MOS. And this is a great one for students getting started in introductory classes to go look at. The Climate Reference Network, I have a download of this because NCEI's is horrible or non-existent. Iowa only, whatever. And the VTech Wawa. So again, I'm in the middle of a cornfield in Iowa, and for whatever reason, the authoritative source of watch warning advisory archives. Is there anybody else that has this? Nobody. And I'll explain why, but the irony of this one is horrible to me. And NCEI, bless their heart, they have their support people, frontlines, have canned email messages that they're sending people when they come looking for this, pointing them to me. And I say, thank you guys, that's really nice of you. And then the Fisher-Porter stuff, I gotta stay in the box. The Fisher-Porter stuff is, you guys remember the Fisher-Porter stations? There's like really cool 15-minute interval automated gauges that went back to the 1970s that the Weather Service has basically pulled the plug on. And NCEI doesn't really understand how to collect it anymore. Well, I hope NCEI doesn't watch this, sorry. But anyway, so let's highlight some of the tools while I talk about these data sets. This is the 1 minute VNCI. There's a latency to this. So it takes about 18 to 36 hours for it to appear, and there's latency in NCI. Believe it or not, NCI, how they get this data, they have a bank of modems, phone modems. They call the ASOSs twice a day to download this data table to get it. ASOS modernization cannot come fast enough for this. It's crazy. The archive goes back to 2000. It's a tough data set to use, but it's there. And there's various tools that can just make simple plots from it, just if you want to go back and look at see what it had. Unfortunately, what happens is a lot of the big events, the ASOS loses power, and then it's dead. Or the calling mechanism to these is very brittle. So like all the data from Hurricane Sandy didn't get saved. Even the stations I had kept power. It's like, boo. The ASOS METAR archive, we talked about this, but one of the cool visualizations you can do is wind roses. And there's other places that have some wind rose capabilities, but you can generate wind roses on demand for over periods of time, whatever. And so people really like wind roses. I have on the website, I have the convention allows you to flip these between meteorological and engineering convention, because unfortunately the engineers hate the meteorological direction convention for wind roses, and so you can flip these on demand between the two. Prism maps, really crude stuff, but you can generate customized daily interval maps from MRMS and Prism and Stage 4 and other things. You can zoom them in on counties, whatever else, and save them off. You can't download the raw data out of this, so I can't be philosophically high horse in this one. The HTML archive, go back in time to view the observations and then what the forecasts were. And you can see how bad HTML forecasts actually are for river stage. It's Autoplot 160, one of the jewels again. Here's the text product data back to 93. What you can't see on the screen here is a discussion written by Max Mayfield about Hurricane Hugo that he wrote. I was like in heaven when I saw this the first time. It was like, this is like unearthing like archaeology. And so this is like an internal message that was not for the public. It went to FEMA or wherever the equivalent of FEMA was back in the day, written by Max Mayfield. It's like, wow. I mentioned about the rectifying the WFSOs. I don't have a text search query on this tool yet. Blame me. But if you send me custom requests, I can quickly do it with my own offline tooling for it. And a common one for weather service, now I don't think there's any weather service in the room, is to go look for a person's first sign tornado warning, for example. They just got to send me some idea about what office were they at and about what couple years they've gone through and hope they don't have a signature like cloud or something. Well, here's the Wawa map. Like, wow, look how cool I am. I'm just archiving this guy. But it's there every 5 minutes. Nextrad archives. The composite product I have is really crude. It's GEMPACK based. It's not very exciting. GridRad and other projects out there have much more advanced mosaics than I have, and then including MRMS now. But this product does go back to 95, so it covers all the level 3 area for Nextrad. I got some single site imagery, but it's very crude. It's not meant for science use. It's just meant for a screening tool, just to have something. And frankly, there's a couple other projects out there now, websites that do this as well. So, but it's GIS ready. You can download it as georeferenced TIFFs, for example. As mentioned about the SPC Outlook search, again, I tried to find something close to where I thought I was going today and plotted up when the last high risk was. So it says, what does it say? When was the last high risk for here?
Washington, Illinois.
Hey, my data set looks good. So this goes back to the mid-1990s, I think, or so. And the tricky part with that old data is that SPC has changed their thresholds over the years. So they used to have a lot more moderates because the moderate risk was a lower threshold. And so anyway, but you can download this further. You can just give you the last one or give you all of them. So in this case, I just filtered by the last event for each threshold, but you can get like all the slight risks for this location, for example. The text product archive of MOS, and so I just have some crude visualizations. In this case, I'm plotting the combination of the 6 and 18-hour high and low, or I'm sorry, I think it's a 12 and 18-hour high and low MOS from the MBS, and then what the dots are what the ASOS actually had for those periods. So you can see how the NBS is trending with time against the MOS. The one on the right is not too much exciting, just a simple bias plot between the MOS and a current analysis. Oh, I archive all the storm attribute table from the Nextrads. So this is the storm, how to describe it? So the Nextrad has up to 32 storms that it's tracking, and it has different attributes on these storms. I've processed basically the entire archive of the Nextrad attribute table. So every radar, you can go through and download all the Nextrad attribute table for all the volume scans back in time. This is just a simple 2-dimensional heat map from, I think this is Chicago's. The top one is storm motion direction versus speed. And so, of course, you see most of the storms here are moving from the west-southwest between something like 15 and 40 knots or something like that. And then the bottom plot is basically by day of the year. This is cool? Yes, I did it. So the bottom plot is the direction versus day of the year. And so why does this have a nice little concave shape to it? Who wants to explain the meteorology to me? I'm just a tech nerd.
Transition to northwesterly flow.
Northwesterly flow, yeah. It's basically the establishment of the southwest monsoon, right? Yep. So it's cool. But the next slide I'll show is what Miami looks like. So there's Miami's radar. So it's fun to be able to illustrate different, understand the different storm modes and storm motions you get in the different parts of the country. And this is one data set that does it. The sounding archive, again, this slide's a little old. SPC has put me out of this business more or less. They got a similar tool now. But it basically, you look at a climatology based on the archive of, like, I think this is most unstable Cape from Davenport, and you can mouse over and pick out what the values were. This is all coming from MetPy's work as far as doing the sounding analysis. The VTech database, let's briefly talk about this. I gotta watch my clock, I'm gonna get in trouble. Oh, I'm doing good. So whatever. And, okay, so I wrote NWS chat, right? And so that was a fun project. But one of the things we needed for NWS chat was a way to summarize the warnings succinctly to users within the chat. So when the media folks are on TV doing whatever, the chat messages come up and it says simply what the warnings were. So as a part of this process of having to process all this text data, I figured out archiving it and stuff like this. And I also come to a bunch of different data sets that allowed me to backfill severe thunderstorm warnings back to 1986. And so the archive of that data goes back to then. But anyway, going forward, this is just a horrible data set to work with. There's so many defects. And whenever I have a policy of my own policy of myself, however that works, but whenever I see something wrong, I squawk to the Weather Service, right? And so I track this. So since August, so 6 years ago, I have 887 defect reports on this data set to the Weather Service. This is one of the reasons why it's horrible to work with. It's kind of crazy what all the troubles you guys see. But one of the unfortunate things is that the private sector has stopped trying to complain to the Weather Service about it because they just don't get responses from them, which is kind of sad. And these are some of these issues are very small, some are very big. Like some of the bigger ones are like when they have a polygon that self-intersects itself. Like it's a invalid polygon. Like how is the public supposed to use this? Anyway. What the fun one is that if you go to NWS's performance branch, which offers a little bit of a download for their data set, you'll find that I have more data than them. Again, you know, when I wake up in the morning, I think, this is not the life I want to live. Like, somebody wrote me that once, like they did audit my stuff, and they said, well, how does the Weather Service not have as many as you do? And I said, well, they probably don't have Puerto Rico for one, because they don't care about Puerto Rico. And then some of the other ones, like from Guam, you know, they might not have done it right. Their systems are like any other IT system, Weather Service, they go down during big events, and they just don't get the warnings into their archive. Whatever. So that's what it is. On my website, the one thing to point out is that VTech, so this coding that went into the Weather Service warnings, it has a nice little encrypted strings in the text, started in 2005. My warnings of severe thunderstorm, tornado, flash flood go back to 86. And what I did is I tried to retroactively assign VTech codes prior to 2005. Again, to keep them predictable, so that when somebody says severe thunderstorm warning 100 from Chicago back in 1995, it's an authoritative or a canonical link to it, so it doesn't change over time.
Hey, Daryl, can you just give a brief explanation of what VTech is?
Yeah, so Weather Service figured out that nobody could figure out how to process their data, process their text files. Like, you had to go through and like look for certain strings that said like NWS Office issues, and then if you saw the word issue, it's like, oh, it's a new event. Or if it says cancels, oh, they canceled the event. But if the word cancel comes later, then it was nebulously, what is going on with this product? And so they basically created a nice little string. Well, you can use the whiteboard since I'm an instructor here, where they like said they're going to use an operational code, and then there's going to be like a event code, and then there's going to be a identifier code for the office, and then a code for the, and then a date string. dun, 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 and then another O or something, just make it fun, and then another slash, and there's a slash up here. But that's right, the code you see in text products. This saved the weather industry's bacon. And so finally, a lot of these different private sector folks had a fighting chance to deal with weather services text products. This was called VTEC, Valid Time Extent Code. Again, just, this is not the life we want to live, right? So.
Mike, you live this life. Yes, I have.
Yeah. Anyway, how are we doing? Am I being somewhat entertaining?
Yes.
All right, right. So there's the VTEC browser. And again, I'm trying to create canonical links to actual warning events. So again, because present day we have VTEC, which has a nice identifier, which is supposed to be unique, but it isn't always unique for a given year. And so when you go to this website and pick, like on the side here, I have tornado warning 2031 from 2011 from Springfield. Who remembers this storm? Joplin, right. So this is one of the tornado warnings from Joplin. But again, it just gives a simple visualization. This is a single site radar from the nearby radar. And it's really crude, right? It's a level 3 product. You're not going to use this for a science thing, but you're just for visualization. But it marries up the polygons, the counties, and the LSRs issued, and you can check through time, whatever else. It's a screening tool. It's not meant to be anything else but that. The SPW polygon search, so this is a tool that allows you to search through the archives by point, or you can do by county. So you can click on the map, drag it to a place, and it'll give you all the storm-based warnings for that point, going back to 2008 or so for the polygon. Actually, it goes back to 2001 with the polygons, because the Weather Service was issuing polygons unofficially starting in 2001. So that uses that data set. This also has tooling for the county versus zones for the products that aren't storm-based or polygon-based. The cow. Who's used the cow? Yes, we get 2 cool kids now. So guys, you look at my website, you'll find all this interesting snark every once in a while, and you'll find barnyard animals and other things like this. So this is a cow that I loved when I was a kid. And so we named something IEM cow, and all it does is a storm-based warning verification. The cool thing about this tool is not the fact that you can see how well or unwell your Weather Service office did during an event, but it merges up the 2 data sets. So you can quickly merge the storm-based warnings with the LSRs and see the union of the 2. And everything's all deep linkable, so you can click links and follow rabbit holes to your heart's desire. But it provides some metrics. When I first produced this, the headquarters was angry with me. They thought this was the end of the world, because they thought AccuWeather was going to, I'm being recorded. They thought AccuWeather was going to take this and hit them over the head with it, the warning statistics, and say, oh, this is the, guess what? Who uses this a lot? AccuWeather. What do they use it for? They use it just to see the Weather Service's data. They don't care about the verification stats. The fact that they can get the warnings and the LSRs together, that's all they care about. So it's not like they're using this to try to write their congressman to get Weather Service privatized or anything like that. This uses the local storm report. So those of you who know the difference between local storm reports and storm data, the storm data is what's official, but it comes out much, much later. And the storm data is not comprehensive. So it doesn't cover everything that's in LSRs. So for better or worse, it's going to run off LSRs. It provides some whiz-bang, gee-whiz, geometry stats on the warnings, whatever. It's live as the page loads. So as soon as you load the page, all the LSRs issued up until that moment, and warnings are there for it. IEM Raccoon. So we got, and all this does is this is a simple thing. I went to an office, Weather Service office, and I was horrified. They had their intern go to my website using the cow and the VTEC browser, and they created a 1,000-slide PowerPoint of all the office's warnings for the year, which was basically a visualization of every warning, and then like just a simple radar summary, whatever. I said, oh my gosh, poor student for one. Let's automate this, and I'll give it a nice name like Raccoon. And so the Raccoon simply generates a PowerPoint for you. So you pick a radar, you pick an office, you pick a time period, pick the warning types you want. It just generates a slide after slide of a PowerPoint with the warning stuff on it. Again, it's not a science thing. It's just an overview thing. And it turns out the Weather Service people love this tool, because all they want to do after a big event is have something with a simple overview that you can click through and say, oh, this warning here was for this location. We need to go look at more or whatever. This warning here didn't have any LSRs with it, whatever. It's just meant to be quick presentation materials and overviews. Autoplot 90 is my favorite. It's the worst autoplot there is. It's got crazy levels of convoluted options to it. But in this case, what you're seeing is a summary of how many flash flood warnings per year does Chicago issue by their zones. And you can see the biggest number there is Chicago for some strange reason. And you get away from the non-urban areas, it goes down for some meteorological reason, of course. So that's autoplot 90. You can also summarize based on the polygons. And so what this does is it looks at the storm-based warning polygons and picks out the last year that location, it's like a rasterized grid here, but the last location that there was a tornado warning for that point. And so you see some neat artifacts showing up in the state where there have or have not been recent warnings. And you guys know where you shouldn't be chasing in this state, so.
Yeah.
But you can generate this on a WFO basis, and you can generate heat maps of these. This is just the one that shows the year of last issuance for autoplot 90. This one does it by counties, so instead of which counties have not been lit up by a tornado warning, when last year was that when they got lit up. And some of these visualizations will make your eyes burn, but whatever. But the raw data is there if you want to use it some more. You can generate maps for WFO bases. This is the number of record event reports. These are the text products that were issued by Office from March in 2012. Most of you probably weren't born yet in 2012, but it was a crazy year a hot year and there was a lot of record events. Oh, you guys are old. Wait, what year are you born?
2002.
2002. Okay.
March 2012. 2000.
Yeah, yes. Good. Oh, I'm 45, so I could be all your guys' parents, so you know, it's humbling. Anyway, so you can generate maps like this, and what's always fun about these maps, and these get some play in the press and stuff, is that I use color sometimes like red for meaning bad and blue for meaning good, and people will say, oh, you're trying to make this office look bad, you're trying to make this office look good. Well, it's not that. It's just that, well, some offices are bad and good, but it's just that when you look at a map like this and you think, why on earth is one office like, if you look at it like Cheyenne, is like at 109 and their next door neighbor is like at 9, you know? Why is there such differences? And this is sort of teases at what I'm trying to drive at with these plots. Another one, autoplot 56, but I don't really care about, but this just plots the climatology of weeks per year, by week a year, the number of events, years with the warning, at least one warning, and the number of total warnings. So you can get at what the warning climatology is based on the warnings. This looks at the storm-based warnings in the text. Sometimes you might notice they have a little attribute down there which shows the location of the threat, its motion, and direction of travel. And so what this is just doing is plotting a kernel density estimate of those values. And so in this case, what I did is I plotted up the entire archive of data, and it's not really labeled, so it's kind of poor of me that I didn't do that. And then the red dots are an actual event. So you can look at how anomalous a certain event was for storm motion against the history. And my standard last slide. I sure hope NCD. Outside, I don't want them to hire me, of course, but I don't need to be in the business of doing half what I'm doing here. So, all right, everybody's not dead. Yay. Oh, so can I do something here and it'll be okay? So let me just go quickly to the website. It's on the internet. And you go to my homepage, and you click on the homepage, and you go to Info, Presentations, because that's logically makes sense, right? And then here you are. There's my slides. And you can go back in time, and you can go back to this nice one, 2011, that says The Illusion of Storm-Based Warnings, and click on that one for April 1st. But anyway. And just quickly, since I'm trying to be funny, my most popular talk, oh heavens, which one is it? I should make like a big sign on it. And you can see my snark just rises with the years, but, oh, sorry. Right here, this one. Oopsie, technology. 2013, I spoke for an academic hour answering this question. How much did it rain in Ames on June 25th, 2010? You want simple answers? You can't handle the truth.
How many answers did you find?
Hey, I'm running the show here, right? I got a couple minutes. Let's go look at it quick. I'll just load the PDF because we just need to look at the last side. Oh, it's Ron Burgundy.
That was more than I expected. Oh my goodness.
You folks don't know the horrors of trying to figure out what ASOS considers to be the top of the hour. when it does all its algorithms. So this is an idealized case where there was a sort of not really bow, but it's a Boeing Echo going through Ames right at midnight, and so we get to look at what was happening with all these different rain gauges at midnight. I'm sorry, and of course a lot of this stuff is not with daylight time; it's Central Standard Time. So a lot of this is at 1 a.m. too. So anyway, all right, I got to top. We're out of time.
So who pays?
Ah.
How do you get funded, I should say? I like this island.
Am I still being recorded? No. All right, so first of all, you're familiar with Google's 20% project idea? So you got these 10x engineers that are supposed to be so cool. You give them 20% of their time to do whatever they want. So I consider this to be my 20% project. My funding does a lot of model research and doing soil erosion of all things. So I'm mostly paid for doing soil erosion, data collection from our weather stations that we have at the ag farms at Iowa State. And there's a couple other projects I can't remember now that I do work on. So I'm a one-off like crazy.
I think we need Diego to be your protege, and he should take over for you at some time when you retire. Questions? We got a bunch of questions. Victor, over there.
So, Daryl, how do you prioritize questions that come in? I mean, you mentioned the for-profit stuff. I mean, are there times when people are like, I will give you money if you just do this? I mean, and how do you deal with that? Do you consult on the side? Or
Iowa has very strict employee laws.
Okay.
Like, we can't get a slice of pizza from Dell during their, literally. Dell used to give pizza, for their hardware things. We can't take pizza anymore. So if I get something in the mail, I give it to a grad student. I say, I can't deal with this. So I just say no all the time. The fact that there are industries being driven off this stuff, I mean, you guys are the same boat with your website. It's just what it is. I mean, I sort of don't feel sorry for them when I go down at some point in time for whatever reason, my lame programming skills, and they like complain up a storm. Yeah. And I say, well, guys, you're not paying us anything. We're like an EDU. Like, why are you basing your workflows off this? Now, what was interesting, brief story, in June of 2019, within the same week, I heard from Google, Amazon, and Microsoft VPs about using our data. And I know they didn't tell me what they were doing, but they all wrote me in the same week. And I said, okay, whatever. And of course, you see all their weather stuff now, and they trained it off a couple of those raster data sets. But it doesn't bother me. But if Iowa State administration noted that, oh.
I think, the only thing that is for certain in data is that it's going to change, right? That's for sure. Can you talk a little bit about some of the new data formats that you see coming? I mean, a lot of the web-based map visualization stuff to me is like GeoJSON, lightweight style text files that are very powerful.
Yeah, you try to horizon scan and see what Google is doing and stuff, and you realize that even though GeoJSON is not really considered cool by them anymore, they were doing protobuf and stuff like this, which are more amenable. The problem with GeoJSON, of course, is you can't just give you a 100 megabyte or 100 gigabyte GeoJSON file and deal with that in memory. It's just not easy. So protobuf is a better program. Anyway, so I try not to look at what the meteorology industry is doing for formats and stuff and try to figure out what the big cloud scalers are doing for formats. And of course, they're doing different things than what WMO does. And the unfortunate thing, in my opinion, is in the United States is that NWS is cowtailing WMO. So when WMO comes up with crazy ideas like Grib3 and stuff like that, and buffer, you want another horror format, buffer, right? Kids, don't use buffer. You do not want that smoke. I mean, yeah. But buffer's coming, right? And it's going to replace METAR at some point. And in some states, and countries, it already has. Like Germany's data is all buffer now, I believe. A lot of them. And Unidata need to show leadership on buffer. Yeah. Unidata member or employee.
You're not wrong, though.
Yeah, I'm not wrong. But at some point, it's going our blissful life of dealing with ASCII text files is going to go away, and we're going to have to deal with buffer and just what it's going to be. But is there better formats out there? I mean, NetCDF is nice, but it still has its issues. I mean, there's no panacea here. And NetCDF, of course, is very domain-specific, unfortunately. HDF, of course, is a much bigger player in medical imagery and all sorts of stuff. So it's kind of selfish to say NetCDF is the gold standard. More. Yeah, you need the mic so that everybody can hear what I'm ranting about.
So you talked about how you try to answer every request that comes through. How do you deal with feature creep?
I don't deal with feature creep. You see the website.
Well, yeah, I'm just saying, like,
Well,
do you, like,
the only time I'll get snarky with them is that if I try to use my telepathy and understand what they're actually trying to do with the data, then I'll try to steer them away to something else. Like, if I can get the impression that what they want, they don't really want, and what if they're asking for, they don't understand what to deal with, I'll try to like cut that off at the bend so I don't have to do something I don't want to do.
like, no, you don't need
Yeah, but feature creep is a problem, and I don't have an answer for that. And I'm academia, so I can do whatever I want, right? So I don't have to deal with a lot of things, thankfully.
Organization doesn't matter if you get to do whatever you want.
Yeah.
Hey, Daryl, moving for students who are, meteorology majors, I guess, to understand more about data formats and the abundance of data that you guys have and other people, what would you recommend them do for their school? How do they learn this stuff? Do you just play on it? And
Yeah, I mean, most schools that have meteorology programs have something either on their Unix systems where they have a file system directory tree that is populated in real time with data as it comes in, written off of LDM or whatever tooling they're using. Just to go in there and just poke around, look at these different data formats and different text files, trying to figure out what's in them. Find interest in automation. Learn things like cron jobs on Linux. Very simple things to do, like you can schedule some sort of script to run every hour that just does simple things like go out to some web service and download some text file or download some value and then put it into a plot and generate a plot for your website and do it in automated fashion with cron jobs and scripts. Just to realize that the beauty of what we do in meteorology is that, that we have a 24/7 pipe of data coming at us all the time. It's really kind of unique for disciplines to have this opportunity and to be just constantly snowed in with data and to be able to try to automate this. For me, it was very appealing and appeasing. And for you folks that have if you're coming up with Victor can talk a lot about this, but he has tried to operationalize algorithms he's written off of real-time data flows, right? So he has some sort of script and algorithm that he wrote off of some data set. He's then cron jobbing that to take some GFS grid or whatever, producing some sort of plot on his website, and trying to do that in an automated fashion. And this is sort of things that your science projects, right? That you want to do as far as discovery of the data and then making more useful products out of it. Because you just don't want to take the raw GFS CAPE data and just create a text CSV file for it, right? You want to do some diagnostics on it. You want to do some climatologies off of it. So just start thinking about this. Learning things like Unix and Linux is very important for this type of work. You can do a lot of stuff on Windows too, and there's a lot of good Windows users, developers out there to do this on Windows. But really, at the end of the day, the cool Windows tools are basically Linux-based right now. And so just go to the, what's the word? If you want to, anyway, just don't settle for Windows. Yeah. Yeah. You probably need the mic, or I'll repeat your question. Just go ahead and I'll repeat your question.
We got it.
Yeah.
I know something that Paul and Mike have tried to hammer into me and then the other meteorology majors here, learning Python.
Yeah.
Beyond that, were there any other languages that you would recommend trying to take note of?
So Python, of course, is the big player right now. Java is the other one. And Unidata, of course, has led the way in both of those platforms as far as developing meteorological tool sets for them. Now, there are other things out there in different languages, but the problem is they just don't have the breadth of the community behind them that those two, Python and Java, do. Some people are big into R, for example. R is a statistical language, and I really would encourage people not to get invested into R and languages like that because they're too domain specific. While you can do cool things with R, you run into walls. At some point, you can't do something in R, and you have no options at that point other than to jump to a different language. In Python, you don't have that. You won't hit a wall. The only walls you hit in Python are speed. At some point, you hit speed walls. But none of you guys want to learn Rust, and so don't learn Rust. But otherwise, so it's just Python and Java. Yes?
So watching your slides, some of those images and hearing what you're talking about, like you're retroactively comparing data sets, I'm looking at these going, well, I know that he ran into these problems, and I lost count of how many of those problems you probably ran into. My question, though, what is the most bizarre technical problem or issue that you've had to deal with?
Yeah, it's so we deal with we're heavily relying on what comes over NOAA port, and so and the NOAA port is weather services satellite broadcast, and a lot of horror comes over NovaPort sometimes, including when offices do like AWEPS upgrades and then suddenly dump files from 5-10 years ago onto NovaPort, and it just comes across. That's kind of, I mean, I'm trying to think off the top of my head anything more exciting than that, but otherwise it's just, weather services dissemination mentality is garbage in, garbage out. If an office produces something garbage, it gets disseminated. They're not going to stop it. And so it's really sad about that is that it's shunted the entire workload to everybody in the world that tries to deal with weather services data. If you want to make products like this, you got to air control up and down the line because weather services does not QC their data before it goes out. It's crazy.
It's what keeps us employed.
Yeah, it's job security, yeah, but I don't want this job though. The other cool thing I was mentioning about the speed is that on the autoplots, in the right-hand corner says the number, and the left-hand corner tells you how quickly it generated it. So you can see how fast some of these plots get generated. Yes?
You said you get the feed from NOAAport. My question is, when did you get rid of your satellite dishes and why?
Because Unidata's feed is so much easier to use. And so our satellite dishes that we had on the roof just were too much work. We didn't want to keep them around. And Unidata's internet feed became so reliable that we can't do it more reliably than what that was. Of course, Unidata, I'm sure you guys know Unidata, but Unidata is so important for what I've done. And I've always tried to highlight the importance of Unidata from their data services and their software to make this happen. Because we would not be in this business without Unidata. Thank you, Unidata, if you're watching.
I have a couple of students here who are not, they wouldn't know what Unidata is. Can you just
Yeah,
summarize?
so, well, the governor manager over there, but basically you have this UCAR NCAR entity, which is a big university conglomerate of people, of universities that are trying to centralize some research capabilities into centralized computing, centralized research, whatever. But a part of this is that this entity needs to be engaged with out in the field with the undergrad and grad programs. And so they're providing some services. Oh, you should be able to answer this one too. But providing services to these universities. Unidata is the specific wing within UCAR's university community program that's to be directly engaging with what the universities and the community colleges and other ways is to support their academic and research work. And so part of that is to provide data set feeds, provide software, and support community development and building. And they put on seminars, they have internships in the summer, they have workshops that students can attend, typically at very low cost.
There's usually funding opportunities to help people get there.
Yeah, funding to get people there and so on. Yeah.
Any other questions? This was really cool. Amazing. Just the data, it's just the possibilities has been incredible. So thank you for sharing, but thank you mostly for doing this.
Yeah, thank you.
Amazing.
I enjoyed the pizza.
So thanks, Daryl.